Good morning, students. Today I am going to do quick revision of spring constant experiment. In this experiment, we are supposed to find spring constant of two springs. See, here is a spring number 1. The spring constant of this spring is K1. We have to find its value. You are given another spring 2. The spring constant of this spring is K2. We have to find out K2. Then apart from that, we have to verify the series combination of springs. So here is a formula for K series. It's given by K1 into K2 by K1 plus K2. In addition to that, we have to verify parallel combination of two springs. The formula for the same is K parallel is equal to K1 plus K2. Now coming to the tabular column, see, this is our tabular column for finding the value of K1 for first spring. In this tabular column, you can see A at the top. A is the reading in the presence of only the weight hanger. It's applicable for all the springs. Okay. Then you can find out K2 using the second tabular column. The loads are varied from 50 to 100 and then to 150. Here is a tabular column for verification of series combination. You can see both A and B. A is for first spring and B is for second spring in the presence of only weight hanger. Then moving to parallel combination. For parallel combination also, A and B are given. You need to note down them in the absence of load or in the presence of only weight hanger. Now coming to the experimental part. Now what I do is, I suspend the first spring like this. I take the weight hanger and I hold it firmly so that there is no oscillation or vibration. I suspend the weight hanger. The moment we suspend the weight hanger, the spring elongates. As a result of that, you can see a reading here. The reading, initial reading, A is equal to 0.5 centimeter. You have to note down the value of A in the tabular column for K1. I will take a load now. The load I am going to take or use is 50 grams. This is 50 grams. I am going to put 50 grams here. The moment I put 50 grams, elongation occurs. Now we have to note down the reading. The reading, as you all can see, is 1 centimeter. Initial reading was 0.5 centimeter and now the reading is 1 centimeter. 1 minus 0.5, that is B minus A, gives you spring stretch or elongation. Now I'll take another load, another 50 grams. I put it here. The spring elongates further. Now the new reading is 1.5. Okay. So by knowing the difference between the new reading and initial reading A, you can find the spring stretch again in the presence of 100 grams. Next you take another 50 grams, put it here. On putting it here, there is further elongation. Note down the difference between the new reading and initial reading, which will give you spring stretch. And using suitable formula, you can find out K1. It is clearly mentioned in the tabular column. So this way we find out K1 for the first spring. Now I'll remove the loads and also the spring. We are done with spring 1. Repeat the experiment with another spring. Spring 2, suspend it here, put the load starting from first with weight hanger, then 50 grams, 100 grams and then 150. From this you get K2 value. Then we'll have to move to series combination. For series combination, you suspend the first spring like this. There is no load attached to the hook. I take another spring number 2. suspend it here. Now it is end-to-end combination, which we call series combination. Okay, we'll take the weight hanger as usual and suspend only the weight hanger, which we call dead load. Okay, now I am putting the weight hanger or the dead load. You can see elongation in both springs. In the first spring, the elongation is 1 centimeter. We call it A. Coming to the second spring, you can see an elongation of 0.5 centimeter. It should be stable. Yeah, it's almost stable now. It is 0.5 centimeter. So A is 1 centimeter, B is 0.5 centimeter. You have to note down these two values at the top of the tabular column. Now I take 50 grams. Okay, put it here. The moment we put 50 grams, elongation occurs in both springs. Elongation produced in the first spring is C. It is 1.5 centimeter, and elongation shown by the second spring is visible here. It is 1 centimeter. It's D. Now both C and D are known to you. By knowing C and D and A and B, we can find the difference between their sum, that is C plus D minus A plus B. C plus D minus A plus B will give you spring stretch. By knowing spring stretch, you can find spring constant Ks. Now we get Ks directly. Okay. Then take another 50 grams. Now if I put another 50 grams, total load will be 100 grams. Once again, note down C here. It is 2 centimeters. And D here, D is 1.5 centimeter. By knowing both C and D, we can find spring stretch again for 100 centimeter. You get another value of Ks. Continue with the experiment by putting another 50. Okay, so this way you get 3 values of Ks. Find their average Ks. This is experimental value of Ks. You also know K1 for first spring, K2 for second spring. Find theoretical value of Ks, because you know the formula Ks is equal to K1 K2 by K1 plus K2. That is theoretical. So theoretical value of Ks must match with the experimental value of Ks we have found now. Okay. Now let us move to parallel combination. I remove the load. Okay. Then I remove the second spring. First spring is here. I suspend the second spring by the side of the first spring like this. Now I take the hook. You recall the way you use the hook. I put the hook here as well like this. Now take the dead load or the weight hanger, suspend the weight hanger. Okay, I suspend the weight hanger at the middle like this. Now elongation is observed in both springs. Elongation in the first spring is visible here. It is 0.3 centimeter. In the same manner, elongation produced in the second spring is also visible here. It is 0.3 centimeter. So A is 0.3, B is also equal to 0.3. Now I take 50 grams, put it here. On putting 50 grams in the weight hanger, both springs show elongation. Now the elongation that is seen in the first spring is 0.5 centimeter, that is C. Elongation in the other spring, that is D, is also equal to 0.5 centimeter. Now C and D are known to you. Earlier we found out A and B. The average of C and D minus average of A and B, that is C plus D by 2 minus A plus B by 2 will give you spring stretch. And using the formula, we have to find out K directly, which is called K parallel. Okay. Now let us continue further by putting another 50 grams. If you put another 50 grams, total load will be 100. Note down C here. In the first spring, it is 0.8 centimeter. In the second spring also it is 0.8 centimeter. Second one is D. Again, by using the formula you can find spring stretch and K parallel. Okay. Finally, you have to find out average of K parallel. You have to repeat the experiment. Continue with the experiment by putting another 50. Now coming to the tabular column, I mentioned about K parallel. Find the average of K parallel. Now K1, K2 are already known to you. Add them, you get theoretical value of K parallel. So experimental value of K parallel must match with the theoretical value of K parallel.